So in the past couple of videos, I kept mentioning that you want to always make sure you cannot do a u-substitution before you just dive in and try doing an integration by parts application. So I want to show an example of that when it turns out to be the case that you can do a u-substitution. So what if we had this integral, 3 ln of 3x over x dx. So you're on a test, right? You're nervous and you just see a bunch of stuff going on here and it looks scary and you think this is clearly an integration by parts problem because we covered integration by parts in lecture, so this must be an integration by parts problem, and you start going around trying to solve it that way. And it's not that you're going to get it wrong. Integration by parts, if you're able to find what v is from dv, you will always be able to get the answer. The thing is, how much time is that going to take you versus a u substitution? So what I recommend is anytime you get to a problem, simplify wherever you can first. For example, we have this 3 in front of the ln of 3x. That's a constant. Pull that out of the integral. And so we'll have 3 times. Now, I could write it as we had it here, ln of 3x over x. But if you want to make sure that this is an integration by parts problem or u substitution, why don't you separate the functions as much as possible? So especially this is the case when you have a rational function. So what I mean by that is write 1 over x times ln of 3x, because this makes it very clear to you what your two functions are. One is 1 over x, one of them is ln of 3x. And then it should be, I hope, apparent that one of these functions is in a way the derivative of the other. Ln of 3x, if you take the derivative of that, you're going to get 1 over 3x, but that's just some constant times x. Here we have 1 over x. These two are related, so it looks like we could do u substitution. So why don't we try that? Why don't we try making u equal to ln of 3x? Well, then if we do du dx, no, not du, dx, well, that's going to be 1 over 3x times chain rule, right? Times 3. Well, the 3's cancel. And you have 1 over x. And then we see that du is equal to 1 over x dx. And I just want to clarify for some people who might be confused about this. Sometimes you'll see this written as dx over x. Literally the same thing. It's just like multiplying. It's just bringing the dx into the fraction. So yes, in case you've ever been confused about that, that's what that is. It's the same, literally the same thing, right? Because this is multiplication. When you see something in front of a dx, it's saying you're multiplying that by dx. Of course, dx is a infinitesimal, so it might not make a lot of sense, but when you integrate, you can do that. Okay, so if we do that, then this integral we had up here just turns into 3 times, well, ln of 3x is now our u, and 1 over x dx, right? 1 over x dx is du. And we see that that is a really straightforward integral to solve. I don't plan on going through and solving that because the point of this is not to show you how to solve, just random integrals or how to do u substitution. The point of this is to teach you about integration by parts. And this video is meant to be an example for when you don't need integration by parts and how to recognize when you don't need it. Okay, I will make some more videos with other integration by parts problems.